All right, so let's see how this works. We're going to find the length of this asteroid over 0 to 2 pi. Now, you want to be careful because, right, we know what this looks like. We saw that earlier. But I'm not going to go from 0 to 2 pi because if you think about it like a displacement perspective, it's 0, right? I'm right back where I started. So instead, I'm going to take advantage of some symmetry here. And I'm going to say that the length is 4 times the integral from 0 to pi halves. Okay? And then the square root of all that business dt. Okay? And so let's look at dx dt, right? You get our hands on all these. So dx dt is going to be 3 cosine squared t. And then derivative of cosine is negative sine. So I'm going to throw that negative sign out front there. And there's my dx dt. And my dy dt then will be 3 sine squared t. Derivative of sine is cosine. Okay, little chain rule there. So my length of that asteroid be 4 times the length from 0 to pi halves of the square root. And then we've got negative 3 cosine squared t sine t squared plus, and then my dy dt dt. And let's just kind of see where this takes us, right? So I've got a 4. Give myself some room here. All right, so 4 integral 0 to pi halves. And then what do we get? We're going to get a 9 cosine 4th t sine squared t plus 9 sine to the 4th t cosine squared t and dt. All right, now let's not get intimidated by this. Let's just kind of see where it takes us. So I'm going to factor out a 9. And let's see, looks like I can factor out a 9 cosine squared t, oh, sine squared t. Well, that's nice because that's a nice perfect square. And then times, well, let's see, what is this first term going to give me? Oh, it's going to give me a cosine squared. Ooh, I am getting hopeful. Plus this, oh, it gives me a sine squared. I love it when that kind of thing happens. dt. And so, of course, this piece is just 1. And so I have 4 integral 0 to pi halves. And then take the square root here, and you got 3 cosine t sine t dt. And this is a lovely problem you might even see in like a Calc 1 course, because I can just bring that 3 out if I want. I'm not going to yet. Let's do a u sub, right? I'm going to let u be, I'm going to choose u to be sine. So du would be cosine t dt. And now my bounds I need to adjust as well. And here's where you need to be careful. Remember at the beginning I said let's go from 0 to pi halves so that we don't accidentally go from 0 to 2 pi and think of our displacement as having been 0, since we're coming back to where we started. here's the deal. If I'd gone from 0 to 2 pi, then sine of 0 is 0, and sine of 2 pi is 0, which means I would have been integrating from 0 to 0. And so that integral will just be 0, but we know that's not accurate because we can see it's arc length, right? So I was smart to go from 0 to pi halves. So let's see here. U of pi halves is going to be 1. U of 0 is 0. I'm not sure why I did that in reverse order, but okay. So what do we get here? We get 12 integral from 0 to 1, and then U du, which is 12 u squared over 2, 0 to 1, which is going to be what? 12 times 1/2. And so we get 6. Okay. There we have it. All right. Next, we want to look at area under a curve. So that's going to be our next little mini lecture here.